fraction we are starting. 2-1, basic assumptions. So here let's solve these problems. So they have 7 plus 3. What is that? This is equal to 10. Alright, 3 plus 7, 10. 2 plus 4, 6. 4 plus 2, 6. Negative 6 plus 8, positive 2. 8 minus 6, positive 2. Okay, what did you notice? Did you notice any patterns? So if I would compare the left side to the right side, I noticed that what I did was I took this 7 plus 3 and I flipped it around to a 3 plus 7. Here, a 2 plus 4, flipped it around to a 4 plus 2. Negative 6 plus 8 to 8 minus 6. So I got the same answer no matter what order I added it in, right? So in math, we need a name for this. So we don't want to just say, oh, you can just flip it. We have to actually call it something. So what we call it in math is a commutative property. What this means is just what we did in the previous slide is we said some number plus some number is equal to the same thing if I flip it. So if I say 3 plus 5, I'm going to still get 5 plus 3, I'm going to still get the same answer. So I'll get 8 here, I'll get 8 here. Doesn't matter how I arrange it. Same thing for multiplication. So if I have 3, let me change the color, 3 times 5 is equal to 5 times 3, then I get the same answer. This is 15 and this is 15. Doesn't matter the order. Once again, this is called your commutative property. If you're still having a hard time understanding this, think of it this way. Think of it as paying 2 people on the same day. Doesn't matter who you pay first. So if I owed 2 people money and I say I'm going to give this guy $5 first and then give the other guy $5 because that way I'll save money. No, it doesn't work that way. So commutative property is talking about this exact thing. Associative property. This is for all real numbers A, B, and C. So A plus B plus C and is equal to A plus B plus C. But what I add first, it doesn't matter. So if I say 2 plus 3 plus 5 and I have 2 plus 3 plus 5 and I pick what to add first. If I add the 2 and 3 first or if I add the 3 and 5 first, I should get the same answer. So let's check. 2 plus 3 is 5. Bring down the 5 is equal to 2 plus 3 plus 5 is 8. 5 plus 5 is going to be 10, which is equal to 2 plus 8 is 10. So we get the same thing. It doesn't matter about what I add first. So this is the associative property, which is dealing with 3 terms if you notice. So this one has 3 terms, A, B, C, and my commutative property has how many? 2 terms. Both are dealing with the order of things. So if I add this one first or that one first, doesn't matter. Or if I multiply this one first or multiply the other one first. So I'll get the same answer. So let me erase this part right here and then show you what it would look like for your commutative or your associative property of multiplication. So we have 2 times 3 times 5, which is equal to 2 times 3 times 5. If I put parentheses around here and parentheses here, then I would get 6 times 5, which is 30. And here I would get 15 times 2, which is also 30. So it doesn't matter, I get the same answer. Alright, and when you add or multiply any 3 real numbers, the grouping or association of the numbers does not affect the result, is what we were talking about. And likewise, think of it as paying 3 or more people on the same day. Doesn't matter who you pay first. So here we're just talking about more people to pay. Rather than 2 people for commutative property, in associative property we are talking about 3 people or terms. Properties of equality. So for all real numbers a, b, and c, the reflexive property, a is equal to a. So to remember reflexive property, try to think of what it sounds like. So in a mirror, you see your reflection. So reflective property or reflexive property is just saying that this a is also equal to a. It's equal to itself. So if you're measuring a table and you say, well, the table is 5 feet, and that is equal to 5 feet. So it's just talking about the same thing. When you're comparing something to itself, that's your reflexive property. Symmetric property is when you're comparing two things. So often in math, you'll work the problem out and you'll say 7 is equal to x. Well, your teacher would say, oh, it's the same thing as x is equal to 7. Well, what you just did right there was your symmetric property. This is saying that my a is equal to b, so also I can say my b is equal to a. My 7 is equal to x, so also I can say x is equal to 7. Transitive property is talking about something a little bit different. So if I have 3 people, let's say person A has $5. Person B has also $5. And person C has $5. So we know that B is equal to C as well. So if I have A, B, and C, then I can say that A is also equal to C. So a nice way to look at it instead, let me organize the work for you. So if I knew that A was equal to B, right, that's from this part, and I know B is equal to C, so I'm going to just continually write it. So B is equal to C. Well, couldn't I just, let me get a shape here, and, well, let's pick black. Couldn't I just block this out? And now what do you see? A is equal to C. This is your transitive property, is that if I know something about A and B, and I know something about B and C, since I already compared A to B, and B was compared to C, I can compare A to C as well. So I think the best way to organize this thought is to think of just blocking it out. So A is equal to B equals C, block it out, A is equal to C. Okay, that's the end of that section. Let's pause it. Okay, Unit 2-2, addition on a number line. So using a number line to add, first we're going to identify, here's our problem, 5 plus -7, and we're going to identify the first number from left to right. So what that means is, like reading from left to right, my first number is going to be 5. So let me get a marker here, and I'm going to find 5 on the number line. So there's my 5, and now I'm going to look at the second number. So find the second number. There it is, -7. I'm going to go that amount away from where you started. So I started at 5, and now I'm going to go that amount away. But which direction do I go? Well, this is a -7. So if it's negative, I'm going to go 7 times to the left. 1, 2, 3, 4, 5, 6, 7. So where did I land? I landed on -2. So 5 plus -7 is -2. Okay, let's do that one more time. So -7 right here. I'm going to look on my number line, find -7. Now I'm going to look at my second number, and I'm going to add 3 to it. So if I'm adding 3, then I'm going to say, okay, this is +3. I'm going to move that many times to the right. So 1, 2, 3, and stop right there. I look at my number, it's -4, so that means -7 plus 3 is going to be -4. So I owe money, I have money. So whenever I see a negative, I want to think of someone owing money. Whenever I see a positive, I want to think of someone having money. This one tip will make it very easy. So before you start, identify if it is a positive or negative number you are working with. So here's a 5. Well, what kind of 5? A negative 5. So if I have negative 5, I'm going to owe $5, right? So negative means that you're going to owe. Okay, positive 7. So if I have a positive 7, that means I'm going to have $7. Have $7, right? Okay, so here we have, I'm going to first, before I start, I want to figure out what my answer would be. So which number is bigger, 5 or 7? Well, 7 is, so I'm going to circle that. That means that if this is my bigger number, after I do this math, I'm going to have to keep it the same sign. So this is positive, so my answer should be positive. So once this is figured out, I can now say, well, what's the difference between 5 and 7? Well, that's going to be 2. So negative 5 plus 7 is a positive 2. Okay, algebra tiles. Here's a visual way to look at what's going on. So we have one negative integer, one positive integer. That's what the red represents, that's what the blue represents. When you can put them together, that makes it 1 minus 1 is equal to 0. And that's your 0 pair. So these essentially simplify to 0 or cancel to 0. So we have 3, positive 3, so I'm going to say 1, 2, 3. We have negative 5, so I'm going to put 5 red tiles. 1, 2, 3, 4, 5. So how many 0 pairs do I have? Remember, it's when I can find a blue and a red. So that simplifies to 0, 0, 0. What do I have left over? So I have 1, 2. So 2, but what kind? A negative 2. So 3 minus 5 is negative 2. So this again is just another way to look at it. So I'm giving you multiple ways to look at the same kind of problem. All right, negative 4 plus negative 8. So this right here, you owe $4, you owe $8. How much do you owe? So it's going to be owing $12. 6 plus negative 2. So you have $6, you owe someone 2. After you pay, how much do you have or owe? Well, 6 is the bigger number, so this is going to be a positive, and what's left over? 4. So here's negative 3 minus 8. You owe 3, you owe 8. So if you owe twice, you're going to only owe. So this is going to be negative 11. So 3 plus negative 10 plus 6. So here we have my brackets work the same as parentheses. I have addition, I have a negative sign, I have another addition sign. So there's a lot of things going on. So I'm going to want to look at PEMDAS, right? So P is for parentheses. I'm going to look in my first parentheses right here. So it's just the number negative 10. So I can't do anything to that. So I'm going to look to my next parentheses. And remember, brackets are the same as parentheses. So what's 3 plus negative 10? Well, if you know there's several ways you can look at it. The one I like is for multiplication, what's a negative times a positive? Well, it's a negative. So I'm going to instead write this as 3. Negative times a positive is a negative. Put a negative right there, or a minus sign. 3 minus 10. And then put your parentheses plus 6. So 3 minus 10 is negative 7 plus 6. Your bigger number is negative 7. So you know that you're going to still owe. So this is going to be negative 7 plus 6 is negative 1. All right. Okay, Unit 2-3, Rules for Addition. Nice thing about this is since 2-2 and 2-3 are so similar, we already covered the things that you would encounter on this section, so you can just go ahead and start the homework for this section. If you have problems, review 2-2. Okay, Unit 2-4, subtracting real numbers. So a definition of subtraction. For all real numbers a and b, the difference a minus b is defined by a minus b equals a plus negative b. To subtract b, add the opposite of b. So say a equals 3, b equals 5, and then you can substitute. So all this stuff is in your book. And the translation of all these letters, all real numbers, the difference, everything that might confuse you is just saying one thing. There are two ways to write subtraction. So I can write it as, let's say my a is 3, my b is 5. So I say 3 minus 5, just like this. I can write it like that. Or I can write it as 3 plus negative 5. So make sure to copy this part down. You want to make sure to have that. So here's our algorithm, fancy word for steps. So we're going to identify if the integer is positive or negative. So 25, positive or negative? Okay, well it's positive, so you have 25 if it's positive, $25 we'll say. 213, positive or negative? Well, it's negative, so you owe $213. So now you're going to want to say which one's bigger, 213 or 25. So think about it. I'll give you a second. What's bigger, 213 or 25? Obviously 213. So since you circled that, that means that your answer needs to be the same sign. So O is negative, so I put a negative right there. So now I'm going to find out the difference between 213 and 25. So I have 213 minus 25, and I'm going to subtract this, carry that. 13 minus 5 is 8. 2, take it to 1. 10 minus 2 is 8, and bring the 1 down, 188. So if you notice, I got a positive here, but my answer is going to be negative. So we're going to just write 188. So the reason why we had to first find out that it's a negative or not is because if you wrote it the same way as over here, 25 and 213, and you subtract, that's pretty weird. You have nothing to carry, it won't work. So don't do that. So we want the bigger number on top, but the problem with having the bigger number on top is you have to remember if it's positive or negative. So my advice is to follow your system of first saying what your answer will be. Is it going to be negative or positive? So we started this saying, okay, well the bigger number is negative, so this one has to be negative as well. Okay, so on this one we have, if you look at this, we have parentheses, we have a minus sign, another minus, so there's a lot going on. So when there's a lot of operation, you got to find some order to it. Order of operations, PEMDAS. Do you see parentheses? Yep, see them right here, right here. Do you see, or let's first do parentheses. I was about to move on. Okay, so we have parentheses here. 22 minus 33, right? What is that? Well, negative 33 is bigger, so I know my answer is going to be negative. Okay, what's the difference between 33 and 22? Well, it's 11. So this is negative 11. I'm going to put my minus sign. Now I have to figure out my parentheses in here. 55 minus 66. 66 is bigger. So I'm going to say that this one's going to be negative as well. So what's the difference? 11. So negative 11 minus negative 11. This is where it gets tricky. So let me put this to the side. Minus negative 11. So we have the rule. We have the rule keep, change, change. So this one right here becomes 11. Change the minus 2 addition, change the negative 11 to positive 11. Oh, I dropped this negative 11. So remember, keep. So I didn't keep it. Make sure that if this is negative 11, that stays negative 11. This is minus, that changes to positive. This is negative 11, the sign changes to positive 11. So now we have that you owe me $11 and you have $11. What happens? You're broke. So it's 0. So this becomes negative 11 plus 11, which is 0. One more way to look at it. Let me make some room. So we have that way. And also, we can think of negative 11 minus negative 11 as a multiplication problem. So if I have negative 11, I'm going to keep this, but I'm going to say what's a negative times a negative? Well, your answer should be a positive. So positive, and then I'm going to put 11. So a negative times a negative 11 is a positive 11. Okay? And that's another way to put it. So you have two ways to memorize what to do with that. Second way is for multiplication. This way is to just memorize by keep, change, change. So make sure to pick which one you want to use. Okay, I have parentheses here again, parentheses minus, so we're going to use PEMDAS. So P is for parentheses, 3 minus 8 is going to be what? Negative 5. Minus, what's negative 15 plus 19? And that's going to be 4. Negative 5 minus 4, I can rewrite this to make it look nice. So I'm taking away the parentheses. That's all I did from this step to this step. So if you owe me 5 and you owe me 4, how much do you owe me? You owe me $9, or just 9. Okay, so 106 minus 492 plus 776. This one has multiple ways you can go about it. So the way that I like to look at it is that I like to first do all my positive numbers. Now, what tells me, what rule that we went over just a second ago, that tells me that I can do this. I'm going to put negative 492 first, then I'm going to add 776, then I'm going to add 106. And we know this is positive because there's nothing in front of it. Well, I moved everything around, so I'm using my commutative property, and then I'm also using my associative property because I'm going to group it like so. So I'm going to first add this together, then I'm going to add that. So let's bring this down. I now have negative 492 plus, what's 776 plus 106? That would be 882. So now I might not like this as well, so I might want to change it. So what property tells me I can change this? So we used associative and commutative on this part. Here we're going to use, this is dealing with two terms. Remember which one deals with two terms. It would be commutative. So commutative property says I can switch this. So I'm going to put 882 minus, got to make sure that I'm not just putting plus 492. It's still a negative. So it's negative 492. Remember, you can read your minuses and your addition signs as positive and negatives. So 882 minus 492. Just to show you the work, this is 0, 7, 18, 9, 3. Answer is 390. Okay. Go ahead and work on your work. Okay, Unit 2-5, the distributive property. Double rainbow is how we remember it. So, distributive property of multiplication with respect to addition. So for all real numbers a, b, and c, a times b plus c is equal to ab plus ac. All they did right there was they said a times b got ab, a times c got ac. Here they want you to understand that you can also go backwards. This comes from what property again? Commutative property. So we're changing the order of multiplication. And you get AB, AC. Or here they wrote BA, CA. So let's see that with some regular numbers. So if I said 2 times 3 plus 1, what would I get? I would do my double rainbow. Word for it is distributive property. 2 times 3 is 6 plus 2, which is 8. Now here's another way to look at it. We have done distributive property before in previous lessons, but I figure this would be a good way to introduce you to the box method. So here we're going into a little bit of geometry because you're actually finding the area of this rectangle. So we know area of a rectangle is equal to length times width. That's how it's related. So now you have to answer. Once I set it up, this is 2 times 3, that's 6, plus 2 times 1, 2. 6 plus 2, 8. So that's my box method. It's just a different way of organizing it. So here's the box method, but with tiles. So what I can do here is my 2 came from here. I have one tile, add them together, you get your 2. I have 3 tiles here, there's your third. I have 4 tiles here, there's 4. So now I'm going to say 1 times 3. What is that? That is 3. 1 times 4, what is that? That is 4. So I'm going to copy that. Now one more time. 1 times 3 is 3. 1 times 4 is 4. So I get this. So if I were to put this to the side and we would do it our traditional way to check our work, we have 2 times 3 is 6, and 2 times 4 is 8. This becomes 14. Here I got my 6 on this side. 3, 4, 5, 6. That's where the 6 came from. 8, 1, 2, 3, 4, 5, 6, 7, 8. I add them all together and I get 14. I'll let you decide if you want to try this one. The algebra tiles are better in class because you have actual manipulatives to work with, but this is just to show you how you would set it up. Simplify each of these. 4 times 3 plus 2 and 4 times 3x plus 2. Very important, very important. Wake up. Watch this slide. You have to know this. Throughout the class, often people make this mistake. So I want you to make sure you understand this slide. If you don't, rewind, watch it again. Okay, 4 times 3 plus 2, right? I'm going to distribute. 4 times 3 is 12. 4 times 2 is 8. 12 plus 8, 20. Okay? Now, you could have also used PEMDAS if you want, and it could have been 4. I'm going to simplify the parentheses first. That's 5. 4 times 5 is 20. And got the same answer, right? So, just so you don't think that you're doing it the wrong way if you already did it. Let me erase this. All right. Now here, distributive property again. 4 times 3x and 4 times 2. So now we have 4 times 3x is 12x, and 4 times 2 is 8. Can I go further with this? So look at it for a second, and your answer should be that you cannot go further. Why? It's because of like terms. So let's review like terms. We have talked about this in class, but this is such a big concept in algebra and all of math that you need to dedicate a lot of time to it. Oh, I don't want to delete all that. Okay, so we have the number x, y. I could say x squared. I could say y squared. I could just keep on going on and on and on forever. I could change this to a z. I could change this to any symbol, and I could even go to different degrees. I could do 3. I could be doing negatives. So this is never ending. So here, my number, let's start organizing all of our work. So my 12, I can put it right there. My 8, you can put it right here. Here's the 12 and 8. they are in the same column. That's why I was able to get 20. I'm staying in the same column. If you look at the other problem, I get 12x when I multiply. So I put 12x right here in the x column. I get 8. My 8 is already over here in the number column. Since these are in different columns, we cannot say they're like terms and add. Since they are not like terms, you have to leave it like this. This is really important that you don't start putting 20x as your answer. Not good. This is not right. So at this point, you want to realize that addition and subtraction, you're always looking at like terms. When you're doing multiplication and division, if I have 3 times 4x, right, I don't leave it like this, because I could, remember, I could write 3 times 4x like this, 3 times 4, because 4x is actually 4 times x, so I could write it like that. So now, if you cover this part up, 3 times 4, what is that? Well, that's 12. And then x, I just bring it down, 12x. So that's as far as I can go. I can simplify this because it's a like term with these two. So 3 and 4 are like terms, 12x. So in multiplication and division, it's a little bit different. But addition and subtraction, if they're not like terms, you cannot go on. So we did the review. Okay, steps. So there's a lot of things, parentheses, multiplication, and addition. So if there's a lot of operations, we want to use PEMDAS. So P is for parentheses. So here's my parentheses. Is there anything to simplify in there? X is in the, so let's do our like term column. There is an X, and then there is a 3. They are in different columns, so we may not simplify. So since we can't simplify in here, we're going to want to take this 4 times x, 4 times 3. 4 times x is going to be 4x. 4 times 3 is going to be 12. Sorry, I skipped it a little bit. Exponents, they're all to the degree of 1, so we skipped that. We're now on multiplication. The thing about multiplication is we know distributive property uses multiplication. So that's why I was able to do 4x plus 12. And then I'm going to bring down the 3. So here I need to identify my like terms. Here's 4x. Any like terms? No. 12. Any like terms? Yeah, 3 is another number. So this becomes 4x plus 15. And that's as far as we go because these are not like terms. So it's as simplified as it gets. So let me move this. Let's go over our steps. First, make sure you're copying this. Use PEMDAS. Okay, for the second one, you're going to want to identify and combine like terms. Okay? And from there, that was it. Just 2 steps for this problem. PEMDAS can be more steps because you're running through PEMDAS. You're going to say, are there any parentheses? There are, but can I simplify? No. Exponents, everything's to the power of 1, so I can't do anything there. Then we got to multiplication, and then from there we were able to go to identify and combine like terms at that point. And actually, let me make something clear. When you're identifying and combining like terms, you're still in the step where you're adding actually, but you need to know this as well. Okay, Unit 2-6, Rules for Multiplication. So identity property of multiplication. There is a unique real number 1 such that for every real number a times 1 is equal to a. So what that is saying is think of any number, okay? Pick any number and test it out on your own. I'm going to pick 3. So my a is equal to 3. You could pick anything you want again. Negative, positive, whatever. It's always easier to start with a positive though. So 3 times 1 is equal to what? So 3 times 1 is equal to 3. So I get out whatever I put in. So if I put in 5 times 1, I get a 5 back. So all this is saying is that your identity property is if I multiply by 1, I'm going to get the same number back. That's it. So nothing else but what I multiply by 1, I get back. So multiplicative property of 0. So again, here's my a times 0 equals 0. I pick any number for a. I'm going to just stick with 3. 3 times 0 is equal to what? So don't look down here, think about it. 0 times 3, 0. I could pick any number here, and I'm still going to get 0. This is called multiplicative property of 0. So the next one, your multiplicative property of -1. So for every real number a times -1 is equal to negative a. So let's start with a positive number before we go to the negative. So I'm going to stick with 3. 3 times -1 is equal to what? Well, positive times a negative is a negative. 3 times 1 is 3. So this is -3 as your answer. So anything I put in, I get the opposite of. So I started with 3, I'm going to get -3. If I start with a -5, let me do this in a different color actually. So if I start with a -5 times -1, it is equal to negative times negative is a positive. 5 times 1 is 5. So I started with -5, I get back the opposite. That's all this is saying. I can pick any number. If I multiply it by a -1, I'm going to get the opposite 1. Okay, property of opposites and products. For all real numbers a and b, you have -a times b is equal to -ab. So let's just simplify what this all means. So this means a negative number times a positive number is going to give me a negative number. Positive times a negative is going to give me a negative, and a negative times a negative is going to be a positive. So here's some pictures to help you memorize what's going on. If there are two negative people, they walk by, they give each other high fives. That's a good thing, that's positive. So two negatives make a positive. So there's some silly picture for you to memorize this rule, that a negative times a negative is equal to a positive. Here, if I have a negative times a positive, negative always wins. So my little cartoon says multiplication says I win. Positive is saying just stay positive. So same sign, positive, opposite sign, negative. So make sure you copy this down. And the same sign would be negative times a negative is equal to positive. And also positive times positive, same signs, gives me positive as well. Here, a opposite sign, like a negative times a positive, is equal to a negative. And I could write this up the other way because of commutative property. So if I wrote positive times a negative, then this is going to be a negative. Okay, so product of an even number of integers is positive. So what this is talking about is how many negative ones are there? Well, 1, 2, 3, 4. So there's 4 of them, right? So I could write this as -1 to the 4th power. It means the same thing as -1 times -1 times -1 times -1, 4 times. So this, if it's a product of an even number, even remember is 2, 4, 6, 8, and ends in 0 as well. If your number ends in any of these, then it's even. So if this ends in 4, this one should be even. So this is a positive 1, right? So your answer is positive. Product of an odd number of integers is negative. So here I have -1 times -1 times -1 times -1 times -1, and this is 5 times. So I can make this equal to -1 to the 5th power. which is equal to, if I have an odd number, it's negative. So this is also negative 1 for my answer. So algebra tiles. So main thing here, since you don't have tiles in front of you, we're going to look at the 4 different ways that over your math career you have seen multiplication written. So we used to use this dot, we have parentheses, which we still use. Used to use X, but since we have variables, it's too confusing. Don't use this anymore. The dot sometimes we use, and we use this as well. So these 3 ways you'll see most of the time. This one, not all the time, but sometimes. So let me put one little mark, because you might see it, but you won't. So over here, algebra tiles as well. So if I were to say 3 times negative 4, another way of looking at this is negative 4 means that you owe $4, all right? And the positive 3 is saying that that's how many people you have to pay. So I have to pay 3 people, and each person I have to pay $4. So altogether, this is going to be 4 plus 4 plus 4. So you have to have negative 12. You owe the person $12. So just a way to look at multiplication is sets. Okay, so helpful tips for multiplication. Make sure you memorize your multiplication table and the rules. And figure out the answer sign, then multiply the numbers. If you do the numbers first, you may forget to find the sign after. So if I had something like negative 7 times negative 5, first I want to say, what's a negative times a negative? Okay, it's a positive. Then I want to do the number. 7 times 5, 35. Instead of just trying to do them both at the same time, this will keep it more organized and less likely for mistakes when you're doing something new. Okay. So take like terms into account. If they are not like terms, like A times C, just write AC. So if I have 3 times 4x, right? So like terms are 3 and 4. This becomes just 12 times x. These two are not like terms, so just write 12x. Means the same. So remember, multiplication is commutative and associative, meaning we can mix numbers around so they are easier to multiply. So we've talked about this thoroughly, is that multiplication is commutative and associative. So read that again. Keep track of what you multiply by either rewriting or crossing the numbers out that you have already multiplied. So if you have a long list of numbers and you're bouncing around multiplying different things, cross them out as you go and write out your answer. And most importantly, for all of math, not just this, pick a system to organize your work and stick to it only if it works. So here, problem. So I have a negative times negative times negative times negative. There's 4 of them. So if I have 4 negative ones, what does that become? Well, even, so it would become a positive answer. So now we're done with the negatives. We don't even have to worry about it. What's 6 times 1? 6. Okay, what's 7 times 10? 70. 6 times 70, what is that? That's 420. So we made a problem that could have been difficult for you, but since we did our negative first, we were able to finish this quicker. So negative times negative, that's going to be positive. Now we're looking at like terms. 2 is a like term with 3. What's 2 times 3? 6. A is a like term with what? Well, nothing. So I'm going to just say A. B is a like term with what? Well, nothing. So I'm going to put 6AB. And I can rewrite this without the plus in front of it, and it means the same thing. So 6AB. So 3.4y plus 1.6s minus 1.9y minus 3.6s. So let me skip to the next slide, because we're going to just go straight to how to get rid of these decimals. So if you wanted to do this one, you would have had to identify your like terms, and then you would have said 3.4y, 1.9y, and we have to line up our decimals. This is a negative 1.9y, so we're minusing. And then I would have to do this, make sure it lines up. My answer would have a decimal right here, 1.6s minus 3.6s. And then we would have had to line up the decimals and answer. Too much work. So over here, I'm going to just show you how to get rid of your decimals. So put everything in parentheses. Now, if I wanted to move this decimal, I would only have to move it once over to the right to make it a whole number, to make it 34. Same thing here, move it once to the right, make it 16. Move it once to the right, make it 19. Once to the right, make it 36. Question is, how do I move it to the right? Well, let's look at this. What's 2 times 10? It's 20. What's 2 times 100? It's 2. And then I had a point here. Bring it over twice. There's 2 zeros in this 100, so that becomes 200, same way as I did this. So what's 2 times 1,000? Equals 2. Have a decimal. There's 1, 2, 3 zeros. I'm going to move it over 1, 2, 3 times. Okay, last one. 2 times 10,000. Right? Yeah, 10,000 is equal to 2. I have a decimal here. There's 4 zeros, so I'm going to move it over 4 times. So this is now 20,000. So that's how I move the decimal spot. So if all the numbers told me that I needed to move it just one time, then that means that I just have to multiply by 10. When I multiply by 10, I move that once, I move that once, I move that once, I move that once. So let's do this slower. Multiply by 10. 10 times 3.4 is 34y. 10 times 1.6, remember we're distributing. 1.6 is going to be positive 16s. 10 times negative, so negative 1.9y is going to be 19y. 10 times negative 3.6 is going to be negative 36s. So this now becomes, I'm looking at like terms at this point, 34y. A like term with that, negative 19y. Make sure you extend this to where this is a negative. 16s, a like term with that, negative 36s. So 34y minus 19y is going to be 15y. 16s minus 36s is minus 20s. These two cannot be reduced any further, so we are done at this point. So fraction buster, like we did this decimal buster, we're going to use fraction buster. But before we start, let's understand the concept with a smaller problem. 3/2 times what will give me 3? Well, I would just want to use the reciprocal, so this has a half on the bottom. That right here, 2 and then invisible 1, so 1 over 2. So 1 over 2, the reciprocal of this is going to be 2 over 1, which equals 1. So if I multiply by the reciprocal over here, then this becomes, let me pick a different color, then this becomes 1, 2 goes into 2 once, 2 goes into 2 once. 3 times 1 is 3, 1 times 1 is 1. So we got rid of the denominator at this point. So here we're going to want to do the same thing. So for fraction buster, we got to pick a number so then we get rid of the denominator. That is our goal. Get rid of the denominator so we don't have fractions anymore. So the number that we need to pick, though, the easiest thing to do is just multiply all three together. But this one's a little tricky because I don't want that third number. Okay? The reason why is because that 4 is repeated. So when it's repeated, I only need to use it once. So I have 4 times 2, which is going to be 8. So I got that from here, 2 and 4. So let me erase that. So this is going to be 8. times a half, right? 2 goes into 2 once. 2 goes into 8 4 times. Plus 4 goes into 4 once. 4 goes into 8 2 times. And now I have to say times what's up here, 3, which is equal to 4 goes into 4 once, 4 goes into 8 2 times. And I'm going to say times what's equal up here, 5. So now we have 4 plus 2 times 3 is 6 is equal to 10. 10 is equal to 10. So if that makes sense, make sure that you learn how to do that fraction buster. If not, send me emails on that and I'll give you more examples. It shouldn't come that quick. It's one of those things where you need to practice as well. Okay, so this problem, we have a lot of operations going on. We need to find some order. We use PEMDAS to do that. Okay, so P stands for parentheses. I look at my parentheses right here and right here. They both have things that are not like terms, Q and W are different variables, so we can't use that. Exponents, everything is to the first power, so there's nothing to do. Multiplication, there is multiplication, but it's in a different form. It's in distributive property. So I'm going to distribute this -2 to 2Q. And when you distribute this, it'd be a good organization, way to stay organized by circling that -2. Because when you're doing that, I'm not going to just say 2 times 2Q. I'm saying -2 times 2Q. Negative times a positive is a negative. 2 times 2 is 4. And then bring the Q down. -2 times positive W. Negative times a positive is a negative. This becomes 2W. Minus -7 times W. Negative times a positive is a negative. I already put it. 7 times W is 7W. They are not like terms. I have to write it like this. Negative times a negative is positive. 7 times Q, not like terms. I have to write it like this. So now I'm going to underline 4Q, and I'm going to look for a like term. I see 7Q right here. Underline 2W, look for a like term, found it right here. -4Q plus 7Q is equal to 3Q. -2W minus 7W, you owe me 2, you owe me 7, then you owe me 9W. These are not like terms, so this is your final answer. Okay, any questions, make sure to email me them and I'll get back to you using YouTube.